So now we're going to look at some algorithms other than the brute force algorithm. They don't always lead us to the optimal solution. That's why this is still an open problem. They lead us to good solutions, and they are efficient algorithms, but they're not always the best solution. So that's the problem, is there's not really one that leads us to the optimal solution every single time. But they do tend to lead us to a good solution. All right, so here's the idea of the nearest neighbor algorithm. We're going to select a starting point. It doesn't matter which of the vertices we start with. We're going to move to the nearest unvisited vertex. So we don't want to visit a vertex twice. So we're going to look for the edge with the smallest weight as we visit the nearest neighbor. And then we're going to repeat this until our circuit is complete. All right, so let's look at an example. Okay, so we're going to look at this one right here. A company needs to deliver a product to each of their 5 stores around the Dallas, Texas area. Driving distance between the stores are shown in this table, and we're going to find a route for the driver to follow, returning to the distribution center in Fort Worth. And we're only going to do part A to begin with. As we get to the other algorithms here, we'll use B and C. But right now, we're just going to do nearest neighbor. All right, so what we're going to do first of all is let's notice there's 4 different cities here, and we are going to go ahead and actually it looks like there's 5, and they've left out Denton down here. So let's make 5 different vertices. We can spread them out as far as we want to. A little bit easier if we have them further apart though, because we are going to connect them all. I'm going to call this one F for Fort Worth. I'll call this one P for Plano, this one M for Mesquite, this one A for Arlington, and this one D for Denton. All right, now we need to connect all of them. So let's start with F and let's connect it to each of the cities. This is how we make it a complete graph. And then let's go to M and let's make sure it's connected to every single other city. And let's go to D and do the same thing. It's already connected to these 2. So P and A. Let's go to A and let's see, it's connected here, here, here. It just needs there. And then if we check P, it's already connected to everybody. All right, now we're going to go and we are going to put the cost along, or in this case, it's the distances is our cost. Fort Worth to Plano is 54. So on this edge between Fort Worth and Plano, we're going to put 54. Fort Worth to Mesquite is 52. So on this edge, I want to put 52. Fort Worth to Arlington is 19. So this edge right here is going to be a 19. Fort Worth to Denton is 42, so this edge will have a 42 on it. All right, now from Plano to Mesquite is 38, so Plano to Mesquite is 38, so I'll put 38 on that edge. From Plano to Arlington is 53, so right here on this edge is 53. From Plano to Denton is 41, so 41 on this edge. I'll just put it right there. It looks kind of like a 9, so I'm going to make it, there we go. All right, now Mesquite to Arlington is 43, so that's here. Put that 43. Let's see, Mesquite to Denton is 56, so that's right here. All right, now Arlington to Denton is 50. That's right here. And let's just double check. It looks like every single edge now has a cost on it, a weight on it. Okay, so Now that we've got them weighted, we're going to do nearest neighbor. Now, it doesn't matter whether we start at Fort Worth or we start at another vertex. It really makes no difference, but I'll start at Fort Worth. Okay, so let's look at Fort Worth and all of the edges that are coming out of it. We have 52, 42, 19, and 54. So we're going to choose our nearest neighbor, which is our shortest link. That's our A here. So now we're in Arlington. Okay, we're in Arlington. We do not want to go back to where we've already been. So we need to look at the other edges and determine which one's our nearest neighbor. So this one's 53, this one's 43, this one's 50. We want to go to Mesquite along this edge, this 43. So we're traveling to Mesquite. Now again, we've already been to Fort Worth, we've been to Arlington. We do not want to go back to either of those cities yet until it's time to return home. So we certainly do not want to travel that route. That'll take us back to Fort Worth. So of the two remaining cities, 38 and 56, the shortest distance is to Plano, 38. And now there's really no choice. There's only one city I have not visited. I have to go there so that I make my rounds. I'll make all my deliveries. So now we have to go to Denton along this one that's 41, and we have to return back to Fort Worth. Now it's just pure coincidence that this looks like a star now. So don't think that they all look that way. All right, but let's list what are, and it doesn't matter which way we go when we list this. We can list going in either direction. So F to A, to M, to P, to D, and finally back to F. Now let's get the cost. Okay, so F to A was 15. A to M was 43. M to P was 38. P to D was 41. And D to F was, looks like 42. And let's add that up. And we get 179. All right, now realize that might not be the shortest length, but it is a pretty good approximation of the amount that we're going to have to travel to go to all 5 of these. All right, so let's look at one more. So let's say we've got this picture here, and we're going to use our nearest neighbor, and we want to again find the best route. All right, and it doesn't matter what we start with. I'll just start with A. In this case, the cost that is on each edge is the cost it takes to travel to that city. So if we start at A, let's look. Let's see, 5.9, 5.1, 4.7, and 4.4. So we're going to choose our nearest neighbor, or the least amount of cost, which will be E. All right, now, again, we're now in E, so let's see, 5.2, 4.0, or 5.8. We're going to choose the least cost, or our nearest neighbor, which will be C. All right, now we're at C. We don't want to go back to A or E, so let's consider 5.6 for D, or 6.0 for B. 5.6 is the smaller one, so we will go to D next. Now, we've covered every single destination except B, so we have to go to B at this point. And now once we've covered B, we got to go home. All right, now let's see what that is. Let's see, we went A to E, to C, to D, to B, to A. And let's get the cost. that was 4.4. And then E to C was, looks like 4.0. And then C to D was 5.6. And D to B was 4.3. And then finally from B to A was 5.9. Let's add that up. And our cost is 24.2. $24.20.